All right, guys, this is part 2 of the exponent rules. We're going to talk about the division rules and the what's called a power of a power rule. Now, the division rule, again, the deal is that you have to have your base the same. It could be a variable or a number, and you're going to subtract them. Okay, so in A, you would just take 7 as your base, and 7 minus 5 is going to be your exponent. So 7 minus 5 is 2, so you're going to have 7 squared. Now let's look at letter B. You'll notice 4 and 8 are, again, what we call coefficients. So if we didn't have the x's here, what would 4 over 8 be? Well, we would reduce that, right? So that would just reduce to a half. Okay, and then you're going to take the exponent, x, and you're going to take 5 minus 2. So 5 minus 2 would be 3. Now, since it is positive, it is going to stay on the top. And this will be our answer. If you'll notice here, you don't really need the 1. So if you just put the x to the third, that would be fine too. So we assume there already is a 1 there. Let's take a look at C. We have 3 different letters. We have an X, we have a Y, and we have a Z. All right, so let's take a look at this. And let's deal with the X's first. So we have 6 minus 3. So that would be x to the third. Now the y's, a couple different ways you can look at it. Basically the y's are just going to cancel each other out. They both have the first power as 1. So 1 minus 1 would be 0. I just like to think of it as basically they cancel each other out. And then if you look at the z's, remember, if there's no exponent there, like we did in part 1, we'll put a 1 there. So it's basically 1 minus 0, which is just going to be z to the first power, or just z. Okay. Now the last one, a little tricky. So again, what are we going to do with the 2 and the negative 6? We're going to subtract them, right? So what would be 2 minus negative 6? Well, if you remember your integer rules, that's just going to be keep, change, change, however you may think about it. That'd be 6 and 2 would be 8. So you would have x to the 8th power positive now. So it's on the top. All right, that is our dividing rules. And then our last rule is going to be what we call a power of a power. It's basically kind of like a double power. And the rule here is you're going to multiply the power of the powers. Okay? So let's take a look at A, B, C, and D. If you look at this first one, you have x to the third, 4, so you can do 4 times 3, which would be 12. Next one, you'll notice your base is 2. So you keep your base. Remember, always keep your base, whether it's a letter or a number. And then 5 times 3 is 15. I have no idea what 2 to the 15th power is. I'm going to leave it like that. All right, let's look at C now. You'll notice there are 3 separate things in here, okay? So we're going to basically, I kind of think of it as like maybe the distribution. So I'm going to distribute the 3 to the coefficient, to the x, and to the y. All right. So I am going to do 3 to the 3rd power, right? Then I'm going to do the 6 times 3, so that's going to be x, so the 6 times 3 would be 18. And then the last one is going to be a 1 there, right? So 3 times 1 would just be y, or y to the 3rd. Now, can we figure out what 3 to the 3rd power is? I think we can. What's that? 3 times 3 is 9. Times another 3 is 27, right? So if you want to, you can just evaluate that. And voila, we're done. All right, last one. What do we do again? We multiply, right? Well, we're going to use our integer rules. So x is our base. -8 times 2 would be -16. And I do not want you guys to leave this as a negative exponent. So if we go back to our rule in part 1, we're going to put that on the bottom, so we're going to make it a fraction, guys. So what we'll do is we'll put it over 1. So while you're doing exponents, the rule is always going to be never leave your exponent negative. Take care of it by putting it on the bottom. All right.